Hi all. So today we are going to discuss about the ozonolysis of alkenes. In the last class we have discussed about the oxidative cleavage of alkenes, no? So here in this session we will discuss alkenes, what happens when alkenes are treated with ozone. Okay, so here let us take a simple alkene like CH2 double bond CH2 ethylene. When it is first treated with ozone, it forms. So here ozone first when treated with alkene, it forms ozonide. So here it is your CH2. This is your ozonide. You just write down this product. It is ozonide, which is highly unstable. So you just place how to write the product. You just replace this pi bond, and instead of that pi bond, insert oxygen between this pi bond and you lift this one. And here instead of this pi bond, you introduce other two oxygens. So this will be like ozonide. This is the way of writing product. It is, we call it as ozonide. So ozonide further undergoes cleavage. Here there are two types of cleavages depending upon the reagents we choose. So if we take oxidative, if we take here ozone, if we take H along with H2O or H2O2, we call it as an oxidative cleavage. So in this oxidative cleavage here, we'll get aldehyde. We will get aldehyde plus ketone, but here under these oxidative conditions, aldehyde is further oxidizes to acid. So finally under these oxidative conditions, here we'll get acid plus ketone. Okay, if ozone is treated under these conditions, we'll get acid, aldehyde plus ketone. Aldehyde is further oxidizes to acid if it is an oxidative ozonolysis. Okay, so if along with ozone, if we take H2O or H2O2. Okay, and the second case, when ozone is after the formation, when ozone is taken with zinc along with acid, here the acid may be CH3COOH, or the second reagent, it is a dimethyl sulfide. So it is these are the reductive ozonolysis. So after the ozonide forms, it is an unstable. If you take these two, here the products are aldehydes and ketones. That's it. Aldehydes plus ketones. These are some rules. Likewise, in the case of an oxidative cleavage of alkenes, we have discussed in the previous session. So here ozone undergoes two types of cleavages after the formation of an ozonide, which is an unstable species. So here when ozone is taken along with H2O or H2O2, here finally aldehyde plus ketone, under the oxidative conditions, aldehyde is further oxidizes to acid. So here what will get, acid plus ketone under the oxidative conditions. And the second one, if we take zinc along with under reductive conditions, in generally it is a dimethyl sulfide, the two reagents, or zinc along with acid is generally acetic acid. So here the products are always aldehydes and ketones. Here you have to remember these points to write the product of ozonolysis of alkenes. Okay, ozonolysis of alkenes and alkanes will discuss separately. Otherwise you will get a little confusion. Okay. Note down these points and we'll discuss some examples. Okay. Now for that alkene we'll discuss, first we'll write CH2. Here we'll take two conditions. Ozone when it is treated with first one H2O. So here what are the products, and here the same the ozone, this is taken along with ozone and dimethyl sulfide. We'll discuss what are the reagents in these two cases. Okay, so first here without writing the ozonide, I'll tell you how to write the products of ozonolysis of alkene. So here likewise you just break this one. So here under these conditions, here you are breaking this double bond, no? So you place two you are breaking. So here instead of this one, here that double bond, one oxygen here and another oxygen here. So here is your CH2 double bond O. Okay, so here what is this one? It is an aldehyde under oxidative ozonolysis. So this is the structure like this. Here C double bond O, two hydrogens I have written clearly, that's it, it is a formaldehyde. So here under these conditions here, this is further oxidizes to acid. I told you, no, first condition. Here under the oxidative conditions, aldehydes plus ketones are formed. Here in this case, two aldehydes are formed. So here I am clearly writing this one, it is a formaldehyde. So here it is further cleaved to acid. So here between this carbon and hydrogen, or between both are similar, no, two hydrogens are there. You break one of this bond, just simply I am telling. Introduce one oxygen because it is an oxidation, no. So it will be converted into HCOOH, which is a formic acid. So aldehyde under the oxidative cleavage, it is converted into acid. So finally, when ethylene is undergoes oxidative cleavage with H2O, what are the products you will get? Here you break this bond or that bond. So introduce oxygen between them. Here 2 moles of formic acid will get under these conditions. Clear? So here just break this bond, one oxygen to this carbon, another oxygen to this carbon. So CH2 double bond O, CH2 double bond O. So here this is the structure, just I have elaborated the structure and written here. So the aldehyde further converted to acid. So finally under these conditions you will get an acid. So here next what you will get under the reduction conditions? Here always the products are aldehydes and ketones. So here one oxygen here and another oxygen here. So this will be CH2 double bond O plus CH2 double bond O. So 2 moles of formaldehyde. H C double bond O H. This is the way of writing products. Okay. So next we'll discuss another example. Here also we'll take 2 conditions. One is oxidative cleavage O3 plus H2O2, O3 H2O2. Write down the products, and here O3 zinc acid. So first identify that is an oxidative cleavage. Under the oxidative cleavage you will get aldehydes and ketones, and aldehydes are further oxidizes to acids. So here you break this double bond, one oxygen to this one, another one oxygen to this carbon. Here it means 2 carbons, no. So what you will get here, it is double bond O, simply C double bond O, C double bond O, CH3, CH3. So it is your CH3 and CH3. Next what will be the product? Here it is ketone. If ketone is formed, no change in this. But if aldehyde is formed, that will be further oxidizes to acid because it is an oxidative cleavage. So here what you will get here, it is C double bond O. Here is your CH3 and H. It is an aldehyde. C double bond O H. It is an aldehyde. So you just break this carbon hydrogen bond and introduce oxygen between them, carbon and oxygen. So here I will write this. CH3 C double bond O OH, it is an acetic acid. So 1 and 2, these are the products under the oxidative cleavage of ozonolysis. This is the simple way of writing product. If you want, you can write the formation of ozonide too. Okay, I told you, no. Here how to write the ozonide? Carbon. Instead of, you introduce oxygen for 1 pi bond and lift that bond, and 2 oxygens like this. CH3H. Because you are writing your theory exams, no. If you take this one, and if you explain the ozonide formation, after the ozonide formation, if you write these products, that will be enough. Okay. So here ozone, which along with zinc and acid. So here what you will get, always the products are aldehydes and ketones. So it is C double bond O, and here is your CH3 plus aldehyde, this is ketone, and CH3 C double bond O and hydrogen, it is aldehyde. Clear this one? This is about ozonolysis of alkenes. Okay, I'll take another example so that it will be more clear to you. Write down the products in these two cases. So here ozone, here it is a reductive ozonolysis, zinc along with acid or zinc. So if breakage of this one, here oxygen here, so it is a reductive cleavage, aldehydes and all 2 molecules of aldehyde. So here it is CH3 CH, it is double bond O plus CH2 double bond O. It is acetaldehyde and it is formaldehyde. H, like this. Similarly, you write the product for this one, O, and here it is your C, reductive cleavage, ketone as it is and aldehyde as it is, CH2 double bond O. Clear? This is about ozonolysis of alkenes. Okay. In the next video, we'll discuss ozonolysis of alkynes. Till then, bye.